We have yet another alternative, which is to sense at the source and feedback to the gate. Okay. Because the drain is not in this picture, we are sensing at the source and feeding back to the gate. I will connect the drain to the supply voltage. Okay, it's some voltage, it's connected somewhere. As far as the biasing circuit is concerned, it's not relevant where the drain is connected to. Of course, in an amplifier, we would like it to be connected such that it remains in saturation region. Now, to sense at the source, I connect the current source I0 to the source terminal, and we have the actual drain current ID in the MOS transistor. Now we are feeding back to the gate. Earlier, in our very first case, we were feeding back to the gate and we connected the source terminal to ground. But of course, now we are sensing the current difference at the source terminal. So we cannot connect the source terminal to ground. Okay. So the source terminal is connected to the current source. And we have to feed back to the gate. Okay. Now the source terminal is not exactly fixed, but still we can go through our chain of reasoning. If ID is too large, that is, it's larger than I0, what must happen? VGS must reduce. Okay. So VGS must reduce. We don't know what the source voltage is, but because VGS equals VG minus Vs, if we are trying to control it with Vg alone, then this says that Vg also must reduce. Okay. And this is the feedback action that we want. That is, if ID is larger than I0, then we must reduce Vg so that ID tends to reduce. Okay. Now let's see what actually happens at the source terminal. ID minus I0 flows into the capacitor, and if ID is higher than I0, what happens is that the source voltage Vs actually increases. Okay. So what's happening to the source voltage is a measure of whether ID is greater than I0 or less than I0. If ID is greater than I0, Vs increases, and we want to reduce Vg. So that means that, like in the previous case, there must be a negative incremental gain between Vs and Vg. That is, if Vs increases, Vg must reduce, and vice versa. So we can connect some block that takes Vs as input and puts out Vg, and it must have a negative incremental gain, meaning its output reduces as the input increases. Okay. Right. So that's the meaning of negative incremental gain. Okay. Now one thing you observe here is that from our earlier discussion, you know that this is Vg and I connect I0 to the source terminal, and